Create realistic pockets with Blendpocket. The Blendpocket command helps to quickly create radii that are suitable for production in a milling pocket. The command immediately generates a geometry corresponding to the cutter diameter and thus also helps to find the right diameter. It produces realistic results even if the pocket has undercuts. This allows you to customize the built-in parts perfectly. The command cannot be found directly in the user interface, but is nevertheless included in the basic license. And with that, welcome to Tips and Tricks on LearnNX. You can find the command under Menu, Insert, Arrow Design, Blendpocket. To integrate it into the user interface, enter Blendpocket in the search field, and click on the magnifying glass to open the search window. If the cursor is over the eye, you can see where the command can be started. Click on the small arrow, and then on Add to Ribbon bar. Home, to integrate it into the user interface. After selecting the milling cutter and the parameters, one click on the surface at the bottom of the pocket is enough to create all the necessary roundings. Only to be able to explain the settings better, I have designed and dimensioned this milling cutter. In addition, I have linked it to the parameters of the Blendpocket command, and so it changes according to my inputs. The diameter is self-explanatory and probably also the lower radius, which is the corner radius of the cutter. The corner clearance parameter defines a corner radius for the cutter path in the corners. This not only produces better surfaces when milling, but also larger corner radii. The corner radius, that is then actually created, is displayed under Wall Blend Radius. Depending on the selected milling cutter diameter, different geometries result for the pocket. 10 mm is too large. At 8 mm the two inner contours are still connected. At 6 mm, they are no longer connected. And at 5 mm, the inner contours are milled correctly. Undercuts can also be milled. This surface is inclined by 10 degrees. Various solution options can now be selected under Angled Wall. And with Cut Floor, the undercut is ignored. I think that's the best solution. In the next test, these steps are to be milled with a spherical milling cutter. After selecting the floor surface, the automatically generated result is incorrect. But the solution is simple. If the automatically infer pocket wall faces option is deactivated, the pocket walls can be selected manually. In this way, it can be processed step by step. Undercuts can also be created with a T-cutter. Just to be able to explain the settings better, I designed and dimensioned this milling cutter again. If this distance is smaller than the depth of the undercut, an error message is displayed. And also, if this length is greater than the height of the undercut. This is actually quite logical and helpful, but a little confusing at first. This pocket also has to be created in 2 steps. At first, make the undercut with the T-cutter. Then follow the corner radii for the pocket. Well, in practice of course, it would be done the other way round. Nevertheless, you can quickly model undercuts that also correspond to the later result, and thus perfectly adapt built-in parts to this geometry. And that brings us to the end of this tips and tricks video. And what topic would you like to suggest for tips and tricks? Just drop me an email at info@learnnx.com.